Hello and welcome to this full tutorial on how to use the concrete mix design beginner template reference to ACI 211.1 for normal strength concrete. So in this example, I use here some kind of real life scenario, real life situation example. And to begin with, you will be required to at least have some details like specification, bill of quantities, and general notes. These are most likely you will find from the concrete inquiries, either from the contractor or from your sales team. So let us proceed. I will show you how to use this in practical application. So as you can go through the process on how to use it based on a real life situation. So let's put in these values: 30 MPa, the specified strength. The cement type is OPC or the type 1 based on ASTM C150. Concrete element is superstructure, and nominal maximum size of aggregates is 19 mm. Slump value is 175 plus minus 25. Standard deviation, we'll consider it's not available up to this time since this is new. So let us say this is empty, but you can put anytime based on your situation. So let us proceed with empty in this example. And the minimum cement content is 350. Water cement ratio is maximum 0.5. So in this example, the required average strength is already been calculated, and it's showing 38.3 or 5,555 psi. So if this is 38, let us use the average strength reference to this table of ACI, and to cover this required strength, you can choose to use the 40 MPa. So in 40 MPa, based on this table, the water cement ratio is 0.42. So you will get the value or the estimated strength value at 28 days, 40 megapascal based on this table. So if it happens that you are using everything according to specification, like your cement or your aggregates reference to ASTM C33, cement reference to ASTM C150, considering everything is being followed in accordance to standards, so most likely you will get also a near value at least to the 40 MPa as suggested by the ACI. So in this example, I tried to use 40 MPa, and so the suggested water cement ratio, of course, it's 0.42. And as per ACI, it suggests that we have to reduce at least 0.02. So I will reduce 0.02, that will be 0.4, due to the fact that we know, or they acknowledge, or they understood that in real life situation, construction team or the drivers will tend to add water as an extra water. So to protect us from this low strength, ACI suggests that at least to reduce 0.02 water cement ratio, which I already did in this example. So the water content as required by the ACI, it suggests 216. However, due to the fact that we are using the new generation of admixture, we can approximately estimate that it can reduce 30% of water. So it will be 151 in this example. You can also ask your supplier of admixture. You can check the data sheet, or you can try trial mix to find out or to verify it. So here the actual water is less than 151. So to cover that, we have to increase a little bit of cement now. Let's say 380. So now it's more than the 151. And for the volume of coarse aggregate, it suggests 0.64 as per ACI, but I will be using less than that, like 0.62. By the way, I would like to add that for the volume of dry rotted coarse aggregate, you can actually use the lower value or the upper value depending on the slump value that you need. Let's say, for example, you need a high value of slump for the pumpable mix design, say 220 slump or 230. So in that case, you just need to reduce to 0.58, the lower value. So it will tend to give you less volume of coarse aggregate. That means you will have a finer mixture. So it will tend to flow or to have a higher value of slump. So it will be much more pumpable. You get the idea. So this is how we create mix design based on ACI 211, which is very flexible. So now if you need a very low slump, for example, for pavement, let's say 50 mm slump. So in contrary to this value, now we have to increase to the maximum or the upper limit as suggested by the ACI, which is 0.7. So now you will have much higher value of coarse aggregate. That means you have less workability, less slump. So therefore it will be suitable for your concrete mix application, which is the pavement. So again, this is how we are using the ACI 211 using this template of mine, the beginner template, which is very flexible, and for the beginner it's really very helpful for the beginner or learners. Anyway, so moving on to the other details, this is the fineness modulus automatically being calculated upon entering or putting this value of the sieve analysis for the fine aggregates. Here I have natural sand and crushed sand, 80% natural and 20% crushed sand. So it will be automatically calculated, and fineness modulus is 2.7. Next, the dry rotted bulk density of coarse aggregate, or the unit weight of the dry rotted coarse aggregate. This is actually combined. So to do that, you have to update the dry rotted bulk density coming from your third-party test report or from your internal test report. So in this example, I have here 19 mm 59% and the 9.5 mm 41% combined together, and the dry rotted bulk density is 1728 kg per cubic meter. Next, for the mass of coarse aggregate, so now we will take the part of coarse aggregate based on the volume of dry rotted coarse aggregate here on top. So let me just go back to my previous assumption, which is 0.62, because I want to be conservative on this presentation. So we have to multiply the dry rotted bulk density to the volume of dry rotted coarse aggregate. So now you have 1070 kg per cubic meter mass of coarse aggregate. Next, solid volume of material except for the fine aggregate. So this is very simple. We just need the sum of all this value, like the cement, the cementitious material, the water admixture, and the volume of air content, and you will get the 0.66 solid volume except for the sand. And so now the remaining will be a solid volume of fine aggregates, which is 0.34. And now we have to go one by one. I will guide you how this calculation or how this value came. Moving on to this table, the ingredients details and batch weights. So let me just correct myself. So the volume of materials except for the fine aggregates is the summation of water, cementitious material, admixture, the coarse aggregate, and the volume of the air content. so that the remaining will be the solid volume of the fine aggregates. Now, in this table, we have batch weight for the aggregates which are in SSD condition or saturated surface dry condition, and we have also batch weight wherein we have aggregates based on the dry condition. And for the water, we calculated it based on the deduction of water due to the fact that the admixture has water quantity or water content, which is in this example around 78.66%. For the volume, we can simply calculate it based on this equation. So simply mass of the OPC divided by specific gravity multiplied by 1000. So everything is on same equation. Okay. But for the fine aggregates, since we have already found the volume here, which is 0.34, we just need to know how much volume for each of these fine aggregate, wherein in this example I have natural sand and crushed sand. So to do that, simply we have to multiply 80% of fine aggregate, which I decided a while ago. So 80% of 0.34 is 0.27, and 20% of 0.34, which is 0.07. So that is the volume. Total volume of fines, of course, is 0.34. So moving on to the mass of the aggregates. For the coarse aggregate, we will simply multiply whatever the percentage of the 19 mm, which is 59%, multiplied to the previously we calculated mass of coarse aggregate, which is 1070. So 59% of that will give us 631 kg. And for the 10 mm or the 9.5 mm, that will be 41% of 1070, which means 439. For the sand, it will be multiply only by specific gravity, since you already know the volume of the natural sand and the crushed sand. So simply we have to multiply by specific gravity multiplied by 1000. So that is the mass of our dry material or dry aggregates. Now for the SSD, the equation will be the dry weight of the aggregates multiplied by 1 plus 0.3%, which is the water absorption. Of course, you will have to take it from the third-party test report or your internal test report. So that is the simple equation. Of course, the same equation will apply to the rest of the aggregates in SSD condition. And the sum of all this value is our fresh density. You can double check it by actual density test. And the volume, which is 1 cubic meter, summation of all this absolute volume of the materials. Another parameter here is the aggregate to cement ratio, just to give you some indication. Of course, that is a typical value for normal concrete. But for the mortar, let's say you'll be using sand only, at least 1:3 ratio. And if you are using nominal maximum size aggregate of 9.5 or 10 mm, around 1:4. So I add this parameter just to give you an idea for the workability. It will help you as a guide. Now moving on to the last part, which is the aggregate grading and combination. So here you can see two graphs. Since this is a basic template for the beginner, so I just want to show you the basic grading, which is the coarse aggregate and the fine aggregate only as per ASTM C 33. At least to show you that your aggregates blending is fitting into the requirement as per ASTM-C 33, give you a guide. So even you have 4 aggregates, you can still um, able to blend it according to the requirement of ASTM-C 33. So to do that, it's better to have this template because it's a little bit complicated if you go through one by one. So this is the combined aggregates, and that will be the equation. This is the lower limit and the upper limit. As you can see, we are within the limit. This combined 19 mm and 9.5, it will give you within the limit, as you can see from this example. The same thing happens to the fine aggregates combined. This is the lower limit and the upper limit. And for the final part, I have here some basic parameters for the purpose of optimizing your mix. Even this is a beginner template, so this template is very generous to give you an idea to create a mix design wherein you can optimize it, even though it's a basic template only. So here, let's say for example, I'll be using 125 mm diameter of pump. So it is suggesting that the mortar, the typical mortar value will be 52 to 55%. In actual, we get 56%. So this is just a typical value. It's not a specification, as I mentioned before. But at least it gives you an indication as a guide. And for example, you use 100 mm, so of course it's in the limit. For the piling, it will be still in the limit. And the other most important parameter here is the base plus air over aggregate voids, wherein ACI itself repeatedly talking about the paste, wherein you have to increase it in such a way that you will cover the voids of the aggregate and to give it some like a lubricant for the pump itself, for you to make it pumpable. So that's why I include this one. It is very useful for you as a beginner, as a guide, that you need such amount of paste so that you can cover the aggregate voids. So it's not like you can just simply enter any value of the cement content. There is actually a way to know what is the minimum amount of cement that we have to put in. Or maybe the fine aggregate can help you also cover. So the fine aggregates can also help you increase the percentage for the paste plus air over aggregate voids. In this example, I use 119%. Very high because I need a pumpable mix for this. But if you will be aiming for a lower slump, like for pavement, 110 or just above 110 is enough as paste plus air over the aggregate. So the idea is simple: just cover these voids. We have to be above these voids. And most of the time, for the high value slump or a very pumpable mix, I'm actually using 120% to 125%. And you can do this by increasing or reducing this percentage by some other way. Like one of them is the sand. You can also try to reduce the volume of coarse aggregate. You can also increase or decrease the cement content. You can also play on the water cement ratio. It will give you an indication to adjust this thing, this percentage. So that is the presentation. I hope this helped you a lot to understand how to use this template, and thank you for watching.